There we go. I think we got it. Okay. So today we are looking at logarithms still. And if you remember that logarithms are exponents, logarithms go with exponentials, just like we said, like salt with pepper and peanut butter and jelly, logarithms and exponentials. And so a logarithm helps us find an exponent. That's all it does, okay? Logarithms help us find the exponent so we don't have to go through that whole thing of guess and check as we go through. So first thing I want you to do is, we had talked about at one time on how to rewrite from logarithmic form into exponential form. So this can look like 2 to some power gives me 4. 2 to some power is 4. What is it? 2. Absolutely. And using the snail, 2 squared equals 4. Let's do it to this next one. 2 to what power equals 8? 3. Because 2 cubed is 8. 2 times 2 times 2 is 8. And then here, 2 to what power is 32? Perfect. 2 to the 5th power is 32. Now watch here. 2 plus 3 equals, is that a true statement? Yeah. So what we're going to be doing today is we're going to see a single log, like I have here, log base 2 of 32, how we're going to be able to break it into multiple logs. That is called expanding, where we're given one log and we're going to write it into multiple logs. It's called expansion. And so hopefully when you hear the word expansion or expanding, you think of getting bigger, you think of more. And that's what we're going to see here with our logarithms, how we're going to expand something. Okay? So today we're expanding our logs. With that being said, we have 3 properties, and I'd like you to number these properties because I'll kind of refer them to their number 1, 2, 3. The first property is called the product property. It's called the product property. It's saying that if I have 2 things that are being multiplied together, I can break them apart using addition, giving each one their own log. Say what? All right, let's say I have this. Log base 2 of 3x. Okay, log base 2 of 3x. I want you all to see that 3 is being multiplied by x. Everybody see that? Okay, and I'm going to be asking you this question over and over and over again. How many factors do I have here? 2 factors, 3 and x. If I have 2 factors, that means I'm going to end up with 2 logs. I'm going to separate these 2 factors, and I'm going to give them each their very own log. It's like if you grew up having to share a bedroom with one of your siblings, and then all of a sudden you get to have your own room. That's what we're looking at here. Right now, 3 and x are sharing a room. Real soon now, we're going to give 3 its own room, and we're going to give x its own room too. But to do that, I need to copy exactly the same log with the same base. So it's log base 2. 3 gets its own room, and they get their own room by an addition symbol, and then log base 2 of x. So log base 2 of 3 plus log base 2 of x. So when the argument, that's the position right there of a logarithm, that's called the argument. I know that's kind of weird. But when the argument is being multiplied together, do you see how that's 3 times x? You need to see that that's multiplication. When that's multiplication, we break it and separate them into their own logs using addition. Multiplication means addition, only in math. All right, the second property is the quotient property. Quotient means something's being divided. The argument in that position is being divided. When we divide, we subtract. All right, so here's an example. If I have log base 2, let's just say 4 divided by 5. Same base 2, doesn't matter. So my 4 is going to get its very own log. And because that's division, I'm going to separate it with a subtraction symbol. And then the 5 is going to get its very own symbol. But pay close attention that they both have to have the exact same base. So log base 2 of 4 minus log base 2 of 5. Then our last property is called the power property. Here's an example of that. I'm going to be using a common log. There is no base. Well, there is a base. It's base 10. But because it's a common log, we don't have to show it. But now my argument has a base of x being raised to the second power. So that's why it's called a power property. When that's the case, this power comes out in front. And I get 2 log x. And actually what that means is I'm taking 2 times log, the common log, x. Those are our 3 properties that we're going to apply to our notes down below. But before we do that, I want to show you something. And I really don't want you to write this down because I want you to just soak it in and try to understand where these are coming from. And I'm hoping then that they'll make just a little bit more sense to you. Okay, so I'm going to put this at the top up here. First semester, I think it was, we did a lesson, a section on exponent properties, where we had x squared times x cubed, or something like that. And if I have x squared times x cubed, what does that equal? Why does it equal x to the 5th? I add the exponents. Where does this sound familiar? When the bases are being multiplied, we add the exponents. When our argument is being multiplied, we add the logarithms. Multiplication means addition. We had x to the 5th divided by x cubed. What did that equal? X squared. When I have division, I have subtraction. I subtracted these exponents. 5 minus 3 gave me my 2. When I have division, I have subtraction. And the last one, I had x squared cubed. What is x squared cubed? X to the 6th. When I have a power, I have multiplication. When you have a power, you have multiplication. Exponents and logarithms go hand in hand. Okay, so that's where these properties come from. All right, let's put this to work. All right, so here we go with our examples, and we will do all 10 of these. So I have log base 5 of x to the 4th. We're going to use principal property number 3, the power property. First thing I'm going to do is I know that I'm going to be rewriting log base 5, but where's that 4 going to go? It's going to go out in front. So I'm going to rewrite that as 4 log base 5 of x. If it's an exponent, the exponent goes out in front. Okay? If it's an exponent, the exponent goes out in front. Okay, look at number 2. Log base 2 of y divided by x. Division means subtraction. How many factors do I have here on number 2? 2. I have a y and I have an x. That is so important to see that. I have a y and I have an x. I have 2 factors, therefore I'm going to have 2 different logs. So the first log is going to be log base 2 of y. And to represent the division, I use subtraction. And then my second log is log base 2 of x. Okay? Now, I'm going to come up here and I'm going to go over to number 6. On number 6, I have log base 5 of 2x to the 6th power. How many factors do I have on number 6? 2 factors. I have a 2, and then I have x to the 6th power. How many logs am I going to have written? 2. 1 for the 2 and 1 for the x. Okay, so the first one for the 2 is log base 5 of 2. Are these being multiplied or divided? Multiplied. So multiplication means addition. Then I'm going to write my second log, but wait a minute. I have an exponent to that 6. Where does that exponent go? Out in front. So I write that as 6 log base 5 of x. And notice that 6 is only an exponent to the base of x, not to 2. If it was to both, there would be parentheses around both the 2 and the x, and the 6 would be outside the parentheses. But that 6 is only an exponent to the base of x. Isaac?
Where'd the 2 go?
Right here. Log base 5 of 2 plus 6 times log base 5 of x. Okay? Okay, number 7. First thing I ask you, how many factors do I have? Kennedy says 3. I agree with her. We have 1, 2, and 3. 3 factors. So how many logs am I going to write? 3. Okay, so the first is pretty simple and straightforward. It's just log base 7 of y. Now 3 and x are on the denominator, so that's a division, so I'm going to use subtraction. But because 3 and x are both on the denominator, 3 and x are being multiplied together, I need to represent that they're being multiplied together. I'm going to use parentheses to represent that those two are in the denominator together. It's kind of like you're holding them in with the parentheses. So 3 gets its own log. It's being multiplied by x squared. So that's an exponent. Multiplication means addition. 2 goes out in front. Log base 7 of x. Close my parenthesis. So let's work through that one again. I have 3 terms, so I should end up with, or 3 factors, so I should end up with 3 logs. 1, 2, 3. So log base 7 of y is my numerator. Then I go to division because these are in the denominator and the subtraction represents the division. And because there's more than one factor in the denominator, I'm using parentheses to represent that. And then I write log base 7 of 3, which is being multiplied by, so I represent that with a plus. The 2 is the exponent, so that goes out in front. So 2 times log base 7 of x. Close my parenthesis. Okay, let's go to number 3. I know we're kind of, yeah, it's math class, but really don't know how to count in order. First thing I have is how many factors do I have? 3. So how many logs am I going to write? 3. So I'm going to start with the numerator, and that's pretty straightforward except for the fact I've got an exponent. So that exponent comes out in front. So I'm going to write 2 log base 4 of x. Now I'm moving into division because the other 2 are in the denominator. So I represent the division with the subtraction. And what's in the denominator gets represented with parentheses. So I have log base 4 of 3, because 3 doesn't have an exponent with it, so there's nothing in front of that log. But y cubed does. So I know the 3 will come out in front, and the 3 and the y are being multiplied, so it's a plus sign. So 3 log base 4 of y, close parenthesis. Number 4. How many factors do I have on number 4? I have 4, so therefore, how many logs am I going to write? 4. 4 factors, 4 logs. So the first I have is log base 7 of 3. Then I'm multiplying this by y cubed. So the 3 has an exponent of it. So this is 3 log base 7 of y. And what's in the denominator is being multiplied together. So that's a division and then parenthesis. And then I have log base 7 of 5. 5 is being multiplied by the x squared. That 2 comes out in front. Ooh, I got a fancy x going on there. 2 times log base 7 of x. Sorry about that x. I will go through that one again. That's about as tricky as they get.
This might be a dumb question, but how come we don't put parentheses around like the first 2 sets of logs?
You are so welcome to do that, but because the way I read this is log base 7 of 3 is being multiplied by log base 7 of y cubed. Okay? So there's really no need for parentheses to be around that. But then when I get to that division, I have the division of log base 7 of 5. If I didn't have parentheses here, it would be like this is being divided by this, and then everything will be multiplied by that. That would not represent, if there was no parenthesis, this wouldn't show up in the denominator. This would just show up as times x squared over here. So to represent that it's in the denominator, keeping that in the denominator, I have to put parentheses. But there's no law against you still putting parentheses around the front too. You're still welcome to do so. Okay, let's look at number 5. Again, similar to what we had on the other ones, but how many factors do I have? 3, so I'm going to have 3 logs. So I'm going to have log base 2 of 7. Multiplication means addition. Exponent of 3 goes out in front. 3 log base 2 of x. Now only one factor is in the denominator, so I don't have to show parentheses. Division means subtraction. Log base 2 of y. Okay, I'm sitting right in front of Harley and she already had that done. Are you guys seeing that as well? Okay, awesome. Good job. Okay, let's look at number 8. And this is where I said, be careful with your exponents because the ones that we've seen so far have only been strictly to that particular base. But on number 8, this exponent 5 belongs to 3, and it also belongs to 4 because it is outside the parentheses. So I have 2 factors, and that little star actually represents multiplication. So this 5 is an exponent to that 3 as well, so I'm going to say 5. Then it's a common log. There's no base, so we assume that to be 10. 5 times log 3, multiplication means addition, plus. The 4 gets the 5 as well. So that's 5 times log 4. Okay? Now the last two look a little trickier, but they're really not. If we remember what a square root means as far as rewriting as an exponent. So the square root of x is the same thing as x being raised to what power? Close. A negative exponent means I take the reciprocal. Square root's not necessarily taking the reciprocal, but you're along that right thought. It's not going to be a whole number. So it's log x raised to, you're right, good job, to the 1/2. You guys are the best class. X to the 1/2. This 1, well, outside of 8th hour, this 1 is there, and the 2 is here. Okay, so the 1, the exponent of that x is the is the numerator of that fraction, and the root is also the denominator. Okay? So I have, go back. So I'm going to have to bring that out in front. So 1/2 log x is how I would write that. And then on number 10,
how did you get the 2 above the log?
that's in the root. It's this. That's the assumed 2. So it's really not above the log. I just don't have it written really nicely, but it's from that root. So like if you look here at number 10, this will explain it. This is the 4th root. The exponent is 3. So this can be rewritten as log x. Exponent stays as the numerator, and the root goes as the root, the denominator, down low. So that can be written as log x to the 3/4, which is 3/4 log x, is how that's written.